Hello everyone, here are some additional examples for Chapter 8, Section 6, and you can use these and reference these whenever you are working on your worksheet that goes along with this. So we're just going to be simplifying and solving some expressions here. So on number 1, we are told to simplify the negative 5 square root of 3 plus 7 square roots of 3. So because we have, I'll say like bases, we have the square root of 3 and the square root of 3 in both of these, then we can just add these together as if, think of it's like negative 5x plus 7x. Well, then we would know to add the negative 5 and the 7 together, which is equal to positive 2. So we'll have 2 square roots of 3. Okay, on the next one, we have 5 square roots of 8 plus 4 square roots of 2. They don't have the same radicand right now, so we should look for something else to do first. For example, the square root of 8. Well, the square root of 8 we can simplify, right? Because if we have 5 times the square root of, square root of 8 is the same thing as square root of 2 times 4, right? Well, the square root of 4 is 2, so we'll take that out as a 2. We're just simplifying a radical expression here. So 5 times 2 is 10, so we'll have 10 times the square root of 2 plus 4 times the square root of 2. And then when we can add those together now, because they both have the square root of 2, so we have 14 times the square root of 2. On the next one, we have negative cube root of 6 plus 2 cube roots of 48. 48 and 6 are not the exact same number here, so we need to simplify that cube root of 48 first. So we have negative cube root of 6, and we'll just leave that there for a second. We have plus 2 times the cube root of, okay, so this time we're going to be looking for powers of 3. Well, 48 is the same thing as 6 times 8, and I chose those numbers because 8 has a cube root. So 8 is the same thing as 2 cubed, right? 2 times 2 times 2 is 8, and then that's 6. So 6 and 8. So since I have 2 to the third power, I can take the cube root of that, which is 2. So I'll take the 2 out. So here I get negative cube root of 6 plus, whenever I take a number out, I multiply it by whatever's in the front. So 2 times 2 is 4. So I have 4 cube roots of 6. Now these have the same radicand, so I can just add them together. So 4 plus a negative 1 is 3. So I have 3 cube roots of 6. Number 4, 25 to the 1/6 power divided by 25 to the 2/3 power. I have like bases, so that means I can subtract my exponents. So here I have 25 to the 1/6 minus 2/3. Well, before I can subtract those, I need to get a common denominator. So I'm going to make both of them a denominator of 6. So I'll have 25 to the 1/6 minus, to make this a 6, I have to multiply it by 2, so I'll multiply the top by 2 as well. So 3 times 2 is 6, 2 times 2 is 4. So 2/3 is the same thing as 4/6. Now they have a common denominator, so I can subtract. So I have 25 to the 1 minus 4 is negative 3 over 6. Well, negative 3/6 is the same thing as negative 1/2. Reduce that fraction. And then I want to get rid of that negative exponent, so I'm going to use that negative exponent property and make it 1 over 25 to the 1/2. And remember, what does that 1/2 exponent tell us? That means we're taking the square root of 25. So 1 divided by the square root of 25 Well, the square root of 25 is 5. So there's our simplified expression. By the way, don't feel discouraged when you're doing these. It'll take a little practice getting used to them, but that's what those problems are that we assign. And the more you work with them, the more you'll understand what you're looking for. And it'll get quicker. Okay, on these next expressions, we are told to solve. So here we have x to the negative 2 power is equal to 1 over 9. What we want to do here is get rid of that negative exponent first, because watch what happens. So that negative 2, we can make it a positive 2 by making this 1 over x squared. So we have equals 1 over 9. So since the two sides are equal, 1 equals 1, so x squared must equal 9. Another way to think about it is to cross multiply. So 1 times 9 is 9, and x squared times 1 is x squared, so x squared equals 9. Now we can take the square root of both sides, but remember, when we're solving, the square root of 9 is both positive and negative 3. Okay, number 7, we have 3 times 3 to the power of x plus 1 times 3 to the power of 2x equals 3 to the 7th. So notice all of our bases are equal to 3 here. So that means, since we have an equation, left side equals the right side, let's simplify that left side first. So we have 3 to the power of, when we have like bases, we add the exponents. Don't forget that this first 3 really has an exponent of 1. We just don't write it there. It's understood. So we have 1 plus our next exponent, which is x plus 1, plus our next exponent, which is 2x. So we still have that as equal to 3 sevenths. 3 to the power of 7. So this left-hand side is 3 to the power of, so you have 2x plus x, that's 3x, and then we have plus 2 equals 3 to the power of 7. So notice in my equation I have 3 to the power of something equals 3 to the power of 7. Therefore my exponents can be set equal to each other. So 3x plus 2 equals 7. Now I just solve for x. So if I subtract 2, I get 3x equals 5, and divide by 3, so x equals 5/3. Number 8. I'm not even going to try to say it out loud because I'm going to get all tongue-tied, but we have this really seemingly complicated expression here, but it's really not so bad. What we're going to do is simplify as much as possible. Things will cancel. It'll be great. Okay, so I'm going to turn this left-hand side into one fraction. Because when I multiply fractions, I multiply straight across. So on the top, I'll have 5x to the 15th y squared over, so here I'll have 4. So this x to the power of 12 times x squared, when I multiply like bases, I add exponents, so I have x to the 14th. And then this y times this y is y squared. So I have equals 4. Well, y squared divided by y squared is just 1, so those will cancel each other out. But this x to the 15th divided by x to the 14th. Remember, whenever I divide like bases, I subtract the exponents. So really what I have here is 5 over 4 times x to the 15 minus 14. And if you want to think about it, these y squareds right there, that's y2 minus 2, because I can subtract those exponents as well. So now I have 5 over 4 times 15 minus 14 is just 1, times 2 minus 2 is 0. Anything to the power of 0 is just 1. So I have 5 over 4 times x equals 4. And then to get x by itself, I'm going to multiply both sides by 4 over 5. Those will cancel. So we'll have, go back this way, we'll have x equals 4 times 4 fifths is 16 fifths, 16 over 5. Don't be mad, but I just realized that example number 5 was cut off of the screen. I don't know if you noticed we went from 4 to 6. So let's jump back and simplify this expression before we go on to the last couple of problems. So to simplify, first on this one, we'll have equals. So like bases multiplied together, you add their exponents. So we'll have 4 to the power of 1/3 plus 3/4. And that's to the 12 over 13. So I need to get common denominators here. So on this one, this 1/3 and 3/4, they have a common denominator of 12. So this one, to make the denominator 4, I'll have to multiply it by 4 over 4. So I'll have 4 over 12. And then on the 3/4, I'll have to multiply by 3 over 3. So I'll have 9 over 12. Now I can add those together because now they have a common denominator. So I have 4 to the power of 9 plus 4 is 13. And then that's all to the power of 12 over 13. But remember, when we have a power raised to a power, we multiply the exponents. Well, 13 over 12 times 12 over 13 is just 1. So that is equal to 4, and that's our simplified expression. Looks a lot better than what we started with. Okay, now let's jump back down to the rest of the problems since we're back on track. Okay, for these last few, we just have to state if it's positive, negative, or not real if we were to evaluate it. So on this first one, what you may want to refer to on all of these is back to that table that says if you have an odd root, an even root with a positive or negative radicand or a root of 0. That little table kind of summarizes what we're looking at here. But number 9, we have negative 10 in parentheses raised to the 1/2 power. So will that be positive, negative, or not real when we simplify it? As it turns out, this one is not real, because a power of 1/2 is the same thing as the square root of that number. So we cannot take the square root of a negative number and get a real answer, so this one is not real. The next one, we have negative 10 to the 1/2 power. So what do you think this one is? It's actually negative. And the trick to these is you have to remember the order of operations. Either please excuse my dear Aunt Sally or PEMDAS, whatever you remember. But remember, it's parentheses, then exponents, then multiplication. So on number 10 here, we have to evaluate the exponent before we can do the negative. So what we really have is the square root of 10, because the 1/2 belongs to the 10, so that's the square root of 10, and then it's multiplied by negative 1. So we can take the square root of 10, that would be a positive number, times the negative 1 in the front would be a negative number. Number 11, what is this one? Positive, negative, or not real? So we have a negative number inside parentheses, so the parentheses are included first. Now we have to evaluate the exponent. So hopefully you figured out that this one is positive. So in the parentheses tells us that the negative 10 goes together first. Then we have the cube root of 10. Our index is 3, and then a power of 2. So if you did it in this order, a cube root of a negative number is negative, and then a negative number squared is positive. Or you could think of it as the cube root of negative 10 squared. Remember, we can put that 2 inside or outside. Well, that would then be the cube root of a positive number. Negative 10 squared is a positive number, and then our answer would be positive. Either way, we get a positive number. And then finally, number 12. What is this one? Positive, negative, or not real? Hopefully at this point you've gotten the hang of it and you have found that this one is negative. And again, exponents, there's no parentheses, so then the next thing we evaluate is the exponent. So the exponent belongs with a 10. So here we have the cube root of 10, and then it's made negative. So the cube root of a positive number is a positive number, but a positive times a negative is a negative number. Okay, well that's it. I hope that that all made sense. If you have any questions, let me know, and have a great day. Bye.